Okay, so the next question that we have here is saying that given pi over 2 less than x less than pi. So this is more like the range which they have given us, okay? They are saying that x is greater than pi over 2 and is less than pi. Yeah. Now, using this range, write tan x in terms of sine x, okay? This is what they're telling us. So what are we going to do, okay? We have to write tan x in terms of what? In terms of sine x. So what are we supposed to do here? So pause for a while and try. Okay, so here, what do I have to do? So this is a very simple question, and most of the lecturers, they really like this type of questions, okay? Yeah, so pay attention. So here, what I'm going to do here is this. We are going to get tan x and convert it into what? Sin x over cos x, just like we were doing, yeah, in the previous part. So we are going to say tan x will be equal to sin x over the cos x, because we know sin x over cos x, we said it's what? It is tan x. So here we are having the tan x but in the other form, okay? So now using this other form that we have uh, write the tan x into, we are going to now convert this form. It should have sin x just, okay? This is what the question is saying. So we're going to say sin x, which is here on top, will now be equal to what? Cos x. But remember, we said that we have the identity for cos x, okay? So we can convert cos x into what? Into sin x. And that conversion that we're going to have will be our final answer, okay? Remember we said that x squared plus y squared, we said is giving us what? 1, using the where we are saying that r is equal to 1, okay? Unit circle, remember that. So now, where is x, we put what? We put, of course, cos squared x plus sine. So this is now sine squared x, okay? Sine squared x will now be equal to what? 1. Very simple. So here, from here, what are we going to do now? Okay, so I can even use now this space here over here. So let me just use this space here. Yeah. So what we're going to do here, we have this identity cos squared x plus sin squared x is equal to 1. So we're going to make cos squared x the subject. We're going to have what? So we're going to say cos squared being equal to, so this cos squared x being equal to, we have the 1 minus the sin squared. 1 minus the sin squared here. So we're going to say sin squared x like that. Okay. So now from here, what are we going to do? We have the cos x here. So here it is cos x. Because we want to replace here, where we are saying that sin x over cos x, we want to replace cos x with just cos x and not the value for cos squared x. So meaning we are making cos x here the subject, okay? Not the cos squared x. So what are we going to do? We square root both sides. So we square root this side and this side, of course. What are we having? So this side, square root and the squared will cancel. Then we are going to have the cos x, meaning here we are beta being equal to the square root of what? 1 minus the sine squared x. Okay, this is now the value that we have here. Square root of 1 minus sine squared x being equal to cos x. So meaning where there is cos x, remember the rule of identities. Where there is cos x, we can replace it with what? Square root of 1 minus sine squared x. But remember, that's the reason why we were given the what? The range, this range that we are given. So the answer should lie between these range that we are given. So what is this? They are saying that x is greater than 90. So remember, the conversion pi over 2 is the same as what? 90 degrees. So let us now try to draw the quadrants, okay? If we have the quadrants like this, where is 90? 90 degrees, it is here. From here to here, it is 90 degrees. So now what we are having here, it is x is greater than 90. So meaning, okay, this x has passed this line going this side, okay? So it has passed that line going this side. So it is here now. And they are saying that it is less than 180 pi, it is 180 degrees, okay? Meaning it is less than 180. It means this value of x, it is not reaching here, okay? It is just in between this point from here to here. It is just here in the second quadrant. So what happens in the second quadrant here? Is cos negative or is cos positive? Okay, so remember we said all students take what? They take chibuku. Okay, yeah, all students take chibuku. So here you're going to say that since all the ratios are positive here, then here it is just what? The sign which is positive. Then here it is the tan which is positive. Then here it is what? The chibuku or the cos which is positive. So here all students, the sign is positive, but the cos here is negative, and we want to replace with cos. The cos here is what? Is negative. Okay, yeah, the one which is positive in the second quadrant is what? Is sine. So meaning sine here will be positive. Yes, will be positive. What of cos? Because we're having the cos is a negative, so meaning cos will be negative, meaning the value of cos that we're going to put here should be negative. Okay, what is that value of cos x? We have it. It is which one? That one that we have solved. So meaning in front of this we're going to put what? A negative sign. Okay, yeah, this is what we're going to do. So in front of that we are putting a negative. So now the final answer will be this. Okay, just wrap this. So it is going to be tan x. Okay, since we are proving that tan x is now equal to this that I'm writing here. Sin x is positive, yes, in the second quadrant it is positive, over the negative now. Negative square root of what? Of cos x. Okay, negative square root of cos x. This is what we're having here. So this cos x, rather, it is not square root of that, but this cos x that we have here was replaced by what? It was replaced by the identity, which is this one. So we are replacing negative now here. Okay, negative the square root of cos x, which is this one, the identity 1 minus sine squared x. Okay, so this negative, you can even write it here. Yeah, so this is now the answer. Okay, these questions, they really love bringing them. Okay, so pay particular attention. Okay, yeah.